Hello dear students, I am Professor Anindo Dash from Achievers, and in this video I will be explaining why physical chemistry is said to be the mother subject in context to the entire chemistry. As we all know that entire chemistry is divided into three integral parts: physical chemistry, inorganic chemistry and organic chemistry. And along with that, there is also analytical chemistry that deals with the instrumentations. But fundamentally, we have three integral portions in chemistry: inorganic, physical, and organic. Out of these three integral parts of chemistry, physical chemistry is often said to be the mother chemistry. And why is it so? Why physical chemistry is said to be the mother chemistry? You have to have fundamental knowledge regarding this notion. Actually, what is chemistry all about? At first, we have to understand that. Then we will come to know why physical chemistry is said to be mother chemistry. You see, as I've already told, the very first question that comes in our mind when we start reading chemistry is, what is chemistry all about? What is the fundamental interpretation of chemistry? So chemistry is all about bond making and bond breaking. It's all about bond making and bond breaking and nothing else. But when we want to interpret bond making and bond breaking processes in context to different reactions, that may be inorganic reaction, that may be organic reaction, at first a fundamental or a rudimentary hurdle has to be passed. And what is that hurdle? At first, it has to be ensured whether that reaction will at all occur in nature or not. Okay, so that is the very first question. And if that is the first question, then which branch of chemistry is going to answer that? None other than physical chemistry is going to answer that. The classical part of physical chemistry deals with a very interesting and very important branch of science, you can say. It's thermodynamics. And thermodynamics is going to answer whether a reaction or a physico-chemical process will at all occur in nature or not. So, logically, you can say that a physico-chemical process has to seek permission from thermodynamics, whether it is feasible or not. So the feasibility is going to be predicted by thermodynamics. Okay. Now, how is the feasibility predicted? If we are acquainted with fundamental thermodynamics, then we all know that if delta S universe is greater than 0, then the process is said to be spontaneous, and if it is equal to 0, then the process is said to attain equilibrium. So this greater than symbolizes spontaneity, and this equal sign symbolizes equilibrium. This another function, another handy state function gives free energy delta G at constant temperature pressure with no non-mechanical work less than or equal to 0. If the change in Gibbs free energy is negative, that is, Gibbs free energy is decreasing under the constraint of constant temperature pressure and no non-mechanical work, then you can say that it's spontaneous. And once the change in Gibbs free energy is 0, that means Gibbs free energy attains a steady value. It will be attaining the minima it will decrease and it will attain a steady value at minima. It will get minimized and attain a steady value, and the change is reduced to 0. In that case, it is going to attain equilibrium. So for any process, at first we have to analyze whether the change in given energy under the given conditions is negative or not. If it is not negative, it is positive, then that reaction will not occur in nature. So any physico-chemical process will always seek permission from thermodynamics, and thermodynamics is the god. It will either reject it or it will permit it. Okay. Next, the second question that creeps in mind is, if it's spontaneous, if thermodynamics has permitted the process, if it has passed through the first test of thermodynamics, then the next question that arises is, what is the rate of that process? Okay. And if we are asked to determine the rate of the process, then we must take the help of physical chemistry once again. Another branch of classical physical chemistry is chemical kinetics, and that is going to determine the rate of the process. Now, in context to chemical kinetics, there are some very important things you have to know. What do we do in a chemical kinetic study? What do we do in a kinetic study? At first, we need to know that. Kinetics begins with kinetic experiment. You have to measure the variation of mass or any mass dependent quantity like number of molecules, number of moles, concentration. Conventionally, we deal with concentration with respect to time. So that is the experiment, that is the preliminary experiment you have to perform at first. And from that very experiment, we will determine the rate law or the rate equation. And from the rate law or the rate equation, we will come to know the order of the components participating in the chemical reaction. And from that, we can predict the mechanism theoretically. So this is the sequence that is followed in a kinetic study. Okay. So from the experiment, we arrive at the theory of mechanism. Okay. So when we are dealing with the mechanism, that means we have arrived at the theory. At first, we have to have the experimental data. From the experimental data, we will be eligible to predict the theoretical interpretation, that is the mechanism of the reaction. Okay. Now, in order to understand the mechanism of the reaction, we have to peep into the subatomic level. Why? Because when we are dealing with the mechanism of the reaction, we will be dealing with the interaction of the electrons. The exchange of electrons will occur, electrons will interact, and there are several mechanisms that is there in the entire pedagogy of chemistry. So, in order to determine the mechanism, you have to peep into the subatomic level, because mechanism is all about interaction of electrons. So electrons at first will be filling up the ABMOs, that is the antibonding molecular orbitals. As the antibonding molecular orbital is filled up, obviously what will happen? It will lead to the cleavage of the bond under consideration, definitely, and then the separated atomic orbitals after the cleavage of the bond will be interacting, and they will result in the formation of new BMOs or new bonding molecular orbitals, and that will lead to bond making. So bond breaking and bond making, they occur simultaneously in this fashion or in a stepwise manner. Either it is concerted or it occurs in a stepwise manner. Okay. So at first we are seeking permission from thermodynamics whether the process under consideration is going to occur or not. If thermodynamics permits the process, then we wish to know the rate of that process. In order to understand the rate of the process, we need to interpret it kinetically. In kinetics, at first what we do, we perform the kinetic experiment. From there we determine the rate law. From the rate law, we are eligible to predict the mechanism of the reaction. But while we are talking about mechanism of the reaction, it is all about interaction of electrons. And in order to understand the interaction of electrons, we must peep into the subatomic level. And for that purpose, what we need to explore? We need to explore another branch of chemistry, and that's not classical chemistry. That's not at the macro level, that is at the micro level. So that branch of chemistry should be able to interpret the microscopic level, and that is none other than quantum mechanics. So peeping into the subatomic level is aided by the quantum mechanical interpretation. But quantum mechanics, you know, students, is a philosophy. You can't see what is happening around at the quantum level through your naked eyes. If you're sitting in a room, you can see the fan is hanging from the ceiling. It's rotating, so you can understand the mechanics because you can see the fan. You can understand there is a tension in the upward direction, its weight is acting in the downward direction, it is rotating, so there is some rotational dynamics occurring over there. So you can understand that because you can see those things through your naked eyes. On the contrary, quantum mechanics deals with microparticles. And the field that we are talking about is quantized, or it's discontinuous, it's not continuous like classical mechanics. So it's absolutely impossible to interpret it because you can't visualize it through your naked eyes. So that's the reason why there is a need of validation of the quantum mechanical interpretation that we are making, and that can be validated by spectroscopy. There are several branches of spectroscopy, my dear students. There can be rotational spectroscopy, there can be vibrational spectroscopy, there can be Raman spectroscopy, there can be mass spectroscopy, there can be nuclear magnetic resonance spectroscopy, there can be APR spectroscopy, there can be ASR spectroscopy, there can be Mosby spectroscopy, and whatnot. Okay. So all these will actually validate this quantum mechanical interpretation. So all these branches, thermodynamics, chemical kinetics, quantum mechanics, spectroscopy, all these are included in the boundary of physical chemistry. So physical chemistry is often said to be the mother chemistry. So that's all, students, and bye bye for now.